You are welcome to today's class with your teacher, Anekwe Christopher Ejike, your chemistry teacher. Enjoy the class. Let's begin by looking at this. If I may ask you, what is this picture depicting? What is happening here? I think looking critically and vividly on it, you will know or you will see that it's a container that is housing two metallic objects with a content, liquid contents inside the container. Is also being connected to a source, power source, battery. Now, in reference to the last class we had, we talked about electrolytes. We talked about electrolytic cell. Electrolytic cell is a container that contains two metallic objects called electrodes, and it also contains electrolytes, where electrolysis happens, meaning where the electrolytic process takes place. Here we can see that inside the electrolyte we have ions, which are the cations and the anion. Why? Because they have been dissolved into solution. They have been ionized, and the electric current is being connected to its power source. And with this, it can be allowed the passage of electric current to pass through them because it has been ionized into solution. And this is what we mean by electrolysis. With this, it can conduct electricity. So the decomposition of chemical compound on all this one is what we mean by electrolysis. And this will take us to another part of what we discussed in our last class, electrolysis. So today's topic is what? Electrolysis, part 2. Part 2, electrolysis. It's expected by the end of this particular class, you will be able to explain the electrolysis of tetraoxosulphate acid or electrolysis of acidified water, also known as acidified water. We were able to also explain the electrolysis of concentrated sodium chloride, also known as brine. You should be able also to explain the electrolysis of copper 2 tetraoxosulphate 6 with different electrodes. Now, lastly, you will be able to state the uses of electrolysis. All right, electrolysis of dilute tetraoxosulphate 6 acid, also known as acidified water. The experiment is being designed in a way that two gaseous substances will be collected at the end of the reaction. And we use what we call Hoffman voltameter. Hoffman voltameter, this is the setup. The electrolyte will be added as the setup X. And the two electrodes used here are platinum electrode or platinum foil. Platinum are the electrodes that are being used here. And how does the reaction go? Now, the ions present in this particular electrolytes are this. In the H2SO4, we have hydrogen ion and the SO4 ion, 2 minus. In that of the water, it will ionize into hydrogen ion and OH minus. Now, it's expected you should know that the reaction that is taking place will be taking place in different electrolytes. This charge will be taking place in the anode and it will be taking place also in the cathode. Now, the reactions are the cathode now. Hydrogen ion, we have only hydrogen ion in the cathode level, so it will migrate to the cathode and there it will take up electron. It takes up electron to form a neutral hydrogen atom. Now, the hydrogen atom there, what will it do? It will react again. It will recombine, or it will combine with hydrogen atom again in order to form hydrogen molecule or hydrogen gas molecule. So it will react to hydrogen atom again to form a hydrogen gas molecule. But in the anode parts, what will happen is that the SO4 2 minus and OH minus, two of them will migrate to the anode. Of course, they will be attracted to that. When they will get to that place, still remember the electrochemical series, where the ion lower in the electrochemical series have to leave, has to be discharged. So in the electrochemical series, OH minus is lower than SO4 2 minus. So being that is lower in the electrochemical series, it will be preferentially discharged and it will lose electron to the anode and become a neutral OH group. What will happen? If it does that, then it will combine again with another OH group atom, OH group, in order to form water and oxygen atom. Then oxygen atom that is being produced will combine with another oxygen atom to produce oxygen molecule. Thereby, it will be collected as a gas. Then in the cathode now, hydrogen gas will be collected as the product, but in the anode part, anode electrode, oxygen will be collected as a gas. So the two products that will be collected here are hydrogen gas and oxygen gas. In the product, the volume of the product will be 2 volume of hydrogen gas and 1 volume of oxygen gas. Now, let's take the summary of the reaction that took place in the cathode and the anode. Now, the cathodic half reaction, that means the reaction that took place, the summary of the reaction that took place in the cathode are 4 hydrogen ion in aqueous solution. It will receive 4 electrons in order to have 2 volumes of hydrogen gas. Then 4 OH minus in aqueous solution will form water, 2 volume of water and 1 volume of oxygen when it receives, when he gives out 4 electrons. Then the summary, the overall reaction will be that 4 electrons will cancel 4 electrons in the cathodic and the anodic reaction. Then the final reaction will now, equation for the reaction will now be 4H plus 4OH minus, both in aqueous solution, then to give 4 volume of 4 atoms of hydrogen gas, then 2 volumes of water and 1 volume of oxygen. That will be the overall reaction with electrolysis of acidified water. All right, let's take another example. Electrolysis of concentrated sodium chloride. Remember, concentrated sodium chloride is also known as brine solution. The apparatus is the same as that of the acidified water, but here, cathode may be platinum, it could be carbon, so anyone, but the anode must be carbon in order to resist the attack of chlorine. That is the only thing difference there. Now, the ion presence, of course, there are sodium ion and chlorine ion. Then that of the water, when it's ionized, it will be sodium, hydrogen ion and OH minus, all in aqueous solution. Reaction that will be taking place at the cathode and the reactions that will be taking place at the anode. In the cathode, which is the negative electrode, sodium ion and hydrogen ion will migrate to the cathode. Still remember the sodium chloride, sodium is concentrated. So when they get to that place, of course it's concentrated, but because the hydrogen is far, far lower than sodium in the electrochemical series, it will be preferentially discharged, not minding that sodium is more concentrated because the distance is very far. So sodium will not be discharged, though is concentrated, rather hydrogen ion will be discharged preferentially. But when you get to the anode, of course, chlorine is highly concentrated, OH, 2 of them will migrate to the anode. But when they get there, chlorine will be preferentially discharged. Why? It is more concentrated than that of the OH, and they are closely positioned. Because that they are close in their in the electrochemical series, the effect of concentration will be more important here because chlorine ion and OH ion are close to each other in the series. Just like we said in the last class, effect of concentration is important when the two competing ions are closely positioned in the electrochemical series. So here, what will be discharged, though is higher in the electrochemical series, is chlorine. Chlorine will be discharged because of the higher concentration that it has. So the reaction that will be taking place there is that chlorine will give up one electron that it has, and it will become chlorine ion, chlorine atom. Then it will recombine to itself to be chlorine molecule. Then at the cathode, we have hydrogen receives electron to become hydrogen atom. It combines again to another atom of hydrogen to become hydrogen molecule. So the two products or gaseous compound element that will be collected or produced at the end of this particular process are hydrogen gas and the chlorine gas or chlorine molecule. All right, the summary of the reaction is that in a cathodic half reaction, 2H plus ion will receive 2 electrons in order to become hydrogen molecule. Then in the anodic half reaction, 2 chlorine ion will also give up 2 electrons in order to become chlorine molecule or chlorine gas. Overall reaction will now be 2H plus 2Cl plus, which is chlorine ion plus, and products. The two products given there is hydrogen gas and chlorine gas. That is for concentration of sodium chloride, brine. Now let's consider the electrolysis of copper 2 tetraoxosulphate 6 using different electrodes. Here, let's use when copper or platinum electrodes are used. When they are being used, the ion present there, of course, are the copper 2 ion and SO4 2 minus, then and the hydrogen ion and the OH minus, that of the water. Then definitely copper 2 and hydrogen ion will migrate to the cathode. When they get there, copper 2 ion is lower than hydrogen ion, so preferentially it will be discharged at the cathode. It will be discharged. Now at the anode, 2 of them, SO4 2 minus and OH minus, they will also migrate to the anode. When they get to that place, OH is lower in the electrochemical series. It will be preferentially discharged. So OH minus will combine with another OH minus to give water and the oxygen atom. Then the oxygen atom will combine again with another oxygen atom to produce oxygen gas, oxygen molecule, gas molecule. Then copper, when copper receives 2 electrons in the cathode, it becomes copper metal or copper solid. That is when carbon or platinum electrodes are being used. But when you use copper electrode, it's a different issue. When you use copper electrode, it will be a different issue. Now, when you use a copper electrode, there are 3 possible reactions or mechanisms that can occur. One likely discharge or mechanism there is that there will be discharge of SO4 2 minus by loss of electron. There will be. Then when it does that, it will form SO4 gas. Now, another possible mechanism is discharge of OH minus. And when OH minus, when it gives up 1 electron, it becomes OH group. Then another major where the point of concentration is the conversion of copper atoms of the anode to copper ion. Now remember, you are using copper as anodes, as electrodes. So here, the ions are discharged and there is no change in composition because the anode will be producing what? It will be producing it will give up 2 electrons to the electrolyte. And that one will migrate to the cathode. And when he goes there, he will receive 2. So it will keep on revolving. It will, instead of going off, the anode will keep on producing, producing copper 2 ion to the electrode. Copper, we keep on supplying it. Instead of going out, it will keep on supplying. Thereby, at the end of the reaction, there will not be any substance that will be discharged, and no change in the composition of the substance that make up the particular reaction, and no change in the color of the electrolyte. Thereby, copper is mainly transferred from anode to cathode throughout the electrolytic process. Note this, very important. All right, we need to look into the laws of electrolysis. We have 2 laws of electrolysis postulated or stated by a man called Faraday. One is first law of Faraday, Faraday's first law of electrolysis. It says that the mass of a substance deposited or liberated at an anode or at the anode during electrolysis is directly proportional to the quantity of electricity passing through it or through the electrolyte, meaning that the mass, if the large mass is produced, it means that large quantity of electricity is being supplied. That the quantity of mass or the mass that will be deposited or liberated is determinant to the quantity of electricity supplied or passed through it. Is being represented mathematically as M directly proportional to Q. But we know that quantity of electricity is equal to current times time. If you equate it, it means that M is directly proportional to IT. And if you open the sign of proportionality, it will now be M equal to EIT, meaning that E is a constant of proportionality, which is an electrical equivalent of a substance. With this particular formula, you can solve chemical questions or questions from electrolysis. Now, second Faraday's law states that when the same quantity of electricity is passed through different electrolytes, the relative number of moles of the element deposited are inversely, this one is inversely proportional to the charge or charges of the ions of the elements. If N is used to represent the number of moles of a substance deposited, and C is used to represent the charge of the substance deposited, it means that N is inversely proportional to the charges of the ion. Then N will now remove the sign of proportionality, N equal to K all over C, where N is the number of mole and C is the charge of the ion. If we make K the constant, K equal to NC, if you have more than one system, 2 or 3 different electrolytes, you can have N1C1 equal to N2C2 equal to N3C3, etc. Continue. This formula can help you to calculate when you have more than 2 or 3 electrolyte or system being connected together in order to find the number of mole or the charges that is being produced or deposited. All right, let's take a few calculations. Calculate the current in amperes that will be deposited, that will deposit 8 grams of calcium from fused calcium chloride in 1 hour 30 minutes. This is wire question 2003 number 4D. With that, if that is the case, calcium always receives in such a case, we know that calcium is in group 2. It will receive 2 electrons, and 1 electron is equivalent to 1 Faraday. And 1 Faraday, as we know, is 96,500 coulomb. So if that is the case, 1 Faraday is equivalent to 1 mole of calcium, and 1 calcium is equivalent to 1 Faraday is for 1 electron, but calcium produces 2 electrons. That means 1 mole of calcium will produce 2 Faradays, meaning that 40 grams, which is the relative atomic mass of calcium, will be deposited by 2 times 96,500 coulomb of electricity. That is 2 electrons. If that is the case, 8 grams of calcium, what will be deposited? You multiply it through, cross multiply, and divide it by 40, which will give you that 8,600 coulomb of electricity. Now, equate it, bring the connecting formula Q equal to IT as I gave to you before, and substitute to make Ki the subject of formula, and you have 8.58 amperes as your final answer. Let's take another calculation. Calculate the mass of copper deposited at the cathode when a current of 0.2 ampere is passed through the solution of copper 2 tetraoxosulphate acid for 35 minutes using copper electrode. This is why question 2013, number 3. Now copper, we know copper 2 is already in the equation, meaning the same way 2 farad, 2 electrons. You bring the ratio Q equal to IT, and the current is 0.2. Time given there is 35 minutes times 60, which is 60 minutes make a minute. You multiply it through, and you find your number of coulomb. If that is the case, 2 farad will now be 2 times 96,500 coulomb, which is equivalent to 2 electron, and it's also equivalent to 1 copper, 1 mole of copper, and 1 mole of copper is 64 grams. If that is the case, what will now, for 420 coulomb of electricity, what will it give us? You cross multiply to find the number of grams, they find the mass when it is now 420 coulomb. You cross multiply and divide it by 2 farad, which will give you 0.14 gram of copper that will be produced. Thank you. All right, let's move to just the uses of electrolysis. It can be used for extraction of metal. Extraction of metal. We can use it in purification of metals. We can use it for electroplating of one metal by another metal. Coating, that is electroplating. We can also use it in industrial preparation of certain chemicals. All these things that are being produced, we use them as a way of producing them, of preparing those chemicals like sodium hydroxide, chlorine gas, hydrogen gas, and others. All right, from what we have done so far, take this following assignment. WAEC 1998, number 12 says describe the electrolysis of copper 2 tetraoxosulphate acid using copper electrode. We just did it now. Will the color of the solution changed at the end of the electrolysis described in this one above? Give reason for your answer. Number 2 says give the products of electrolysis of dilute tetraoxosulphate acid using the following materials as anodes, or as electrodes. You can use, one is copper rods, another one is carbon rods. What will the product be when you use copper rod and when you use carbon rod? Then B part of it said for each of the processes you describe in that A above, write the anodic half reaction. State how the electrolysis affects the pH of the solution, which is of the electrolyte. 1991, number 5 question. And finally, 0.45 gram of a metal M was deposited when a current of 1.8 amperes was passed for 12.5 minutes through a solution containing M2 plus. Calculate the relative molecular mass, relative atomic mass of M. This is WAEC question 1997, number 14B. For further inquiry and discussion, You can consult your essential chemistry. You can read understanding chemistry. You can read new school chemistry, compiled part question, and you can also contact me with my WhatsApp line, which is 08065573229, or you can email me at christo116@gmail.com.